Okay, good morning, all of you. So, so today let us start with our new topic of 10th class, that is quadratic equation. Okay, so today we will deal with our next topic, that is quadratic equation. Quadratic equation. Okay, so let us define the term. What is the meaning of the term quadratic equation? Um, Before discussing about the quadratic equation, let us discuss about the quadratic polynomial. Okay, as in our earlier classes, we have studied about the quadratic polynomial. Okay, so what is an equation? When we equate any quadratic expression equals to 0, then it is converted into a equation. Okay, so we can write when 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 a quadratic expression when a quadratic expression when a quadratic expression is equated to 0, when a quadratic expression is equated to 0, then it converts into a then it converts into a quadratic equation. Then it convert into a quadratic. Okay, so we can write any quadratic expression that is defined in variable as x when equated to 0, then it is a quadratic equation. Okay, now we come to our first topic in quadratic equation, that is general expression for quadratic equation. Okay, so we come to our first topic, that is general general expression general expression for quadratic equation. General expression for quadratic equation. Okay, so let us write down the general expression for quadratic equation. What is the general expression? We can write like this. Okay, that is ax square plus bx plus c is equals to 0. That is the general expression for a quadratic equation, where we can write where a should not equals to 0. A means coefficient of the x square, and we can write where a, b and c, where a, b and are real constant, where a, b and c are real constant, means values of a, b and c can be real values. Okay, so this is the general expression for a quadratic equation. Okay, now let us take few important cases. What will happen if a is not a is equals to 0? Okay, so let us take few important cases. So we can write some important cases, some important cases. Okay, now what are the important cases? Let us come to the first case, that is, okay, we are taking the first case. In this equation, if a is equals to 0, if a is equals to 0 but b not equals to c not equals to 0. Okay, we are taking the first case. If value of a is equals to 0 but values of b and c are not equals to 0, then what will happen? If we will put these values, then this equation will convert it into bx plus c is equals to 0. Now here the coefficient of the highest term is equals to 0. That means it is not a quadratic equation. Now it is a linear equation, because here the power of the variable x is equals to 1. So now it is no more a quadratic equation, it is a linear equation. We can write when the coefficient of x square is equals to 0, then it will convert it into a linear equation. Okay, now let us come to the second case. That was our first case. That is the second case. We can take the second case. Okay, if we are writing if a is equals to 0, okay, as well as b is equals to 0. A is equals to 0, b is equals to 0, but c is not equals to 0. Okay, a is equals to 0, b is equals to 0, but c is not equals to 0. Then this equation will convert it into c is not equals to 0. Then this equation will convert it into c is equals to 0. Now according to mathematics rule, c is equals to 0. Okay, that is not valid because 2 cannot be equals to 0. So it is a contradiction. So it is a contra contradiction. Okay, because c is not equals to 0. Now let us come to our next case. We come to the next case, that is third case. Let us come to the third case, that is if we are taking the values of a is equals to 0, as well as b is equals to 0, as well as c is equals to 0. If all the three quantities a, b and c become 0, then what will happen? Then we will get a situation that is 0 is equals to 0. Okay, now in this case, this equation will convert it into identity. Okay, so in this case it is an identity. It is an identity because an identity is satisfied for many values of a, b and c. Okay, so whenever we get an equation 0 is equals to 0 or 1 is equals to 1, okay, LHS is equal to RHS, then such type of situations are an identity. Okay, because if you want to understand this, we can take a simple example. We can take one simple example, that is a plus b whole square. A plus b whole square is an identity. It can be written as a square plus 2ab plus b square. Now this identity is satisfied for infinite many values of a and b. Okay, if we substitute any value of a and b, this identity will always hold. Means if we put any value of a and b, LHS will always be equals to RHS. So it is infinitely many values, infinitely many rules. Okay, so these all are the few cases on which the expression of the quadratic depends, that it is a quadratic, linear, or identity, or it is a contradiction. Okay, now let us come to our next topic. That was all about the quadratic equation, general expression of the quadratic equation. Okay, now let us come to our next topic, that is nature of the roots. Okay, so our next topic is, that is nature of the roots. You can write, that is nature of the roots. Okay, now for defining the nature of the roots depends on the one parameter, that is discriminant of the quadratic equation. That is, we can write the discriminant of the quadratic equation like this, that is d is equals to b square minus 4ac. That is the discriminant of the quadratic equation. Now how the nature of the roots depend on the value of the discriminant. We can classify it into like this. We can take the few cases. In the first case, if d is greater than 0, in the first case we are taking the value of d is greater than 0. In the second case we are taking the value of d is equals to 0, and in the third case we can take the value of d as less than 0. Now let us come to the first case. When d is greater than 0, what will happen? When d is greater than 0, then the graph of the quadratic polynomial will be like this. It will cut the x-axis at 2 points, means this equation will have two distinct roots. So here we can write it is two real and distinct roots. Two real and distinct roots. If t is greater than 0, then the quadratic polynomial will have two real and the distinct roots. Both the values are different. Now we come to the second case. If d is equals to 0, then graph will be like this. It will touch the x-axis, means d is equals to 0. So in this case we can write it has two real and equal roots. Two real and equal roots. That is the case for d is equals to 0. And for the last case, that is d less than 0, the graph will lie above the x-axis or below the x-axis. Okay, graph can be like this. So in this case, the roots are imaginary. Okay, roots are imaginary. Roots are imaginary. Okay, so if d is less than 0, then the case will be like this. Now let us come to the further classification of d greater than 0. We can classify it in the next manner like this. If we are taking the few cases, uh, if d is a perfect square, if d is a perfect square and a, b and c means coefficient of x square, x and the constant term are rational, are rational, then we can write, then the equation will have, then it has rational roots, then it has rational roots. If d is a perfect square and a, b, c and are the rational, then it will have the rational roots. Next, if d is not a perfect square, second case, if d is not a perfect square, but a, b, c are rational and a, b and c are rational, then it has, irrational root, then it has irrational roots. Okay, so depending on the value of d, whether it is a perfect square or not, we can conclude that the roots are rational or irrational. Okay, and we can write the one more important property of the irrational root. Here we can dictate, we can write an important property that, okay, here we can write irrational roots, irrational roots always occurs, in conjugate pairs. Irrational roots always occurs in conjugate pair. Means, conjugate pairs means if one root is of the form, we can write, if one root is of the form, okay, if one root is of the form, if one root is of the form a plus root b, then other root will be, other root will be of the form a minus root. Means these roots always occurs in conjugate pairs. That is the property of the irrational roots. Okay, so that was all about the nature of the roots. We will solve few questions that are based on the nature of the roots in our next class. Thanks for today.